small heading, that is convectional current theory. Or box போட்டு கூட எழுதிக்காங்க, convectional current theory. This theory was propounded in 1928 by Arthur Holmes. And the objective of the theory was to establish the mountain building process. How mountains are formed. This is the objective. How mountains are formed அப்படிங்கிற மாதிரி கொண்டு வராரு by Arthur Holmes. So in that theory, he made an assumption that there is mantle convection responsible for the heat transfer inside the earth. முன்னாடி first classல evolution types of earth's crust layers nalla paakumbodhu we made a statement that core is the molten, outer core is in the molten state, the hottest part, and the crust. இவ்ளோ தூரத்துக்கு heat transfer நடக்கணும்னா என்ன பண்ணி இருக்க முடியும்? Conduction is possible, but it will take trillions and millions of years. Core la irundhu heat transfer aagradhukku, right? Radiation is also quite possible, but there is no vacuum in between, so that radiation can heat faster. Crust and mantle have one more property. What is that? Presence of radioactive elements. So according to Arthur Holmes, he believed that the heat transfer from the core to the earth's crust is between mantle nadula irukku illaya. So convection is happening in the mantle. There is a movement of material. Convection na idana, convection is the physical movement of material. Why? Because he believed that the sima layer is in a molten state. Arthur Holmes, enoda mantle is in which state nu nambanaru? It is in a molten state nu nambanaru. Adanal da the convective currents possible nu. Arthur Holmes theory padipom, adukapram we'll question, we'll ridicule, because we know mantle is never a molten state. Mantle is in which state? Solid state. Only the upper mantle is in molten state. We know the idea, but we listen to Arthur what he wanted to say. So he believed that the sima is in molten state. So a molten object will have which type of physical process in heat transfer? Convection. So convection is sollumodu movement of particle, vertical movement of particle. Illaya? Margin eludunga. The convection ingirudhu up and down motion or vertical movement. And the particular example edupom illaya, water molecule, heating the water molecule ngra madri or circular movement, up and down move agirudhu. Okay va? Convection, up and down, vertical, circular nature. Okay, ஏனா இது ஹீட் ஆயிடும், மேல போய்டும், மேல relatively cold ஆன air molecule, water molecule அதை replace பண்ணும். அப்போ heat transfer நடக்கும்போது இது ஒரு circular motion. Convection மாதிரியே இன்னொரு physical term, that is advection. Advection அப்படிங்கிறது horizontal movement. Horizontal movement of advection அப்படிங்கிறது horizontal movement. Mostly இது எங்க நடக்கும்? wind படிப்போம்ல. what is wind? air in motion தான் wind ன்னு சொல்வாங்க. wind எப்படி இருக்கும்? windங்கிறது ஹாரிசான்டலா தான் இருக்கும். high pressure to low pressure, low pressure to இது எந்த zone? horizontal. இதே என்னோட air மேல கீழே மூவ் ஆச்சுனா convecting இது air current ன்னு சொல்லுவோம். ascending air current, descending air current. movement of air, windங்கிறது horizontal. அப்ப இது என்ன? advection. ஏன் இந்த terms கொடுக்கறேன்னா உங்க ஆன்சர் ரைட்டிங்ல இதெல்லாம் தான் வேணும். ஓகே, advection of air அப்படிங்கிற மீனிங் என்ன கனோட் பண்ணுது? ஹாரிசான்டல் மூவ்மெண்ட். என்னோட விண்ட் சிஸ்டம், சர்ஃபேஸ் விண்ட குறிக்குது. இந்த ட்ரைசெல்லுலார் மெரிடோனியல் சர்க்குலேஷன் பார்ப்போம் இல்லையா, அப்போ ஆகிற கரண்ட்ஸ் என்ன? கன்வெக்டிங் கரண்ட்ஸ். difference புரியுதா? So இப்போ Arthur என்ன நம்புறாரு? Arthur believed that the heat transfer from the core to the crust is through mantle, and the heat transfer is very well established by which process? Convection process. When convection to happen, the mantle has to be in which state? The mantle has to be in molten state. He didn't suggest mantle. He believed that the sima is in a molten state. What is sima? Sima is the layer beneath Sial. இப்போ we can correct that the sima according to Arthur, or the process according to Arthur, was happening inside a asthenosphere, not entirely mantle. கான்செப்ட் புரிஞ்சுக்க முடியுதா? ஏன்னா asthenosphere தான் molten state. So அவர் என்ன சஜஸ்ட் பண்றாரு? அப்போ convectionல there are two important current system. If this is my crust, this is my crust, the convective current, the hot air or the hot heat can be transferred through convecting currents, and these currents diverge, and through divergence they will lose their energy and they will cool down. After cooling down, the cooler currents would converge down. So in the madri alternative system of currents, alternative system of cells of currents da entire crust la irukku. So if this is my crust, so I have two important limb systems. One is the ascending convective currents, which are warmer in nature. So lower zones, core da warm. அப்ப கீழ இருந்து மேல வரக்கூடிய ascending convective currents are of warm nature, and after ascend ஆகுதுன்னா they are losing their energy or losing their heat. அப்ப heat lose ஆனா அந்த hot currents எல்லாமே cold natureக்கு போகும். அப்ப cold current would redistributing the heat தானே அதோட வேலை. அப்ப ஹாட் ஆன இடத்துல இருந்து கூலான இடத்துக்கு போகுது அப்படின்னா கூலான இடத்துல இருந்து ஹாட் ஆன இடத்துக்கு போகணும். அப்ப அந்த colder convective currents would sink down. Yeah, and this process is entirely happening in a circular manner. That is what convection is all about. Appa convection la there are two aspects, that is ascending convective currents denoted by your blue arrows, and your descending convective current which are denoted by your downward arrow, white color arrow. Now, idu ennadu? In the blue line represents the crust. Crust is subjected to two important forces now. The ascending warm convective current is hitting the crust from beneath. அப்ப அந்த crustல எந்த மாதிரியான force feel ஆகும்? ஒரு force கண்டிப்பா இருக்குமா? In which direction this particular convective currents are moving? They are diverging. Appo what kind of force they are experiencing? They are experiencing a tensional force. Okay, the crust is experiencing a tensional force. Now crust has been pulled into two different directions. So possibilities are there, the crust will crack open. Renda kidiyirthukana possibility. So ascending convective currents will hit your crust, and the ascending current will diverge, thereby inducing a tensional force in the crust, and it facilitates what? Facilitates the tearing up of my crust. Appo enna nadakum? The possibilities are more that the magma, idu enna ascending convective current na molten state la irukkudiya rocks da adu. Appo enoda magma can easily outpour through the diverging zones. The concept புரிஞ்சுக்க முடியுதா? Now what is happening when the convective currents are descending down? When currents are descending down, it is pulling together the two different air mass, two different crustal features together, convergence. அப்ப இந்த இடம் so called currents would experience which kind of force? Compressional force. Compression nadanda, crust would get deformed. Okay, they are pulled together. So here, in case of ascending convective current, it will facilitate the lava flow, and it will easily pour down over the region, forming smaller ridges. Mountains, yeah, ridges, yes. And what is happening through convergence? Convergence, collision of your crustal features, deformations, and these are nothing but trenches. So when Arthur Holmes came up with this particular idea, the seafloor spreading, the observations or discoveries found a real meaning towards the entire process. This is easy to convective current simple. Ascending current na enna nadakum, the crustal feature will tear down and it will facilitate the lava flow. Whereas when convective currents are descending down, the entire crustal feature is subjected to compressional force and crustal deformations will happen more often. Right? So these are the two important factors.